Why is the Hohmann transfer orbit efficient for orbital maneuvers? Imagine needing to move a satellite from one orbit around Earth to a higher or lower one. You want to do it with as little fuel as possible. That's where the Hohmann transfer orbit comes into play. It's a clever way to change orbits using the least amount of energy. This method uses just two engine burns, which saves fuel and keeps the spacecraft lighter. The first burn pushes the spacecraft from its current circular orbit into an elliptical path that touches the new orbit. The second burn happens at the farthest or closest point of that ellipse to make the orbit perfectly circular again. This approach is smart because it uses the natural physics of gravity and motion. The elliptical transfer orbit is designed so that the spacecraft only needs to change velocity at two key points. These are the periapsis, which is the closest point to Earth, and the apoapsis, the farthest point. Applying the engine burns at these points makes the velocity changes more effective. Since the total change in velocity, called delta V, is minimized, the spacecraft uses less fuel. This is very important because fuel mass affects how big and expensive the spacecraft can be. Many space missions, including satellite adjustments and interplanetary trips, use this method. For example, India's Mars Orbiter mission used a Hohmann transfer orbit to reach Mars efficiently, saving fuel and money. Sometimes, this transfer can be combined with gravity assists or other maneuvers to make the trip even more efficient. Overall, the Hohmann transfer orbit is a smart way to move between orbits because it makes the most of the physics of orbital mechanics. It helps save fuel, reduces costs, and makes space missions more practical. When time is not the main concern, this method is often the best choice for changing a satellite's orbit around Earth or even traveling to other planets.